Hi, Assalamualaikum. So, we are doing this video to do a report about group assignment assessment 3 for MAT210. So, we are from group number 1. Before that, let's meet my team. We are from Aim Force Athlete Sdn Bhd. So, first, my name is Muhammad Nurfan Hakimi bin Suhairi, and we also have Muhammad Akmal Hakim bin Shahran. We also have Muhammad Iman Wafiq bin Abdul Rahim. We also have Nur Irfan Haziq bin Iskandar Rizal. And lastly, we have Azrif bin Azhar. So, without further ado, let's solve some problems. So, I pass it to Azrif.
So here is the first question. So we have given the logical expression in bracket P and Q or in bracket P and R and P in bracket P or not R. So now the instruction is to draw a circuit that represent the above logical expression. First, I will explain the symbols used in this expression. So the symbol that looks like a triangle stands for N. The symbol looks like V stands for OR, and you can see in the expression that before R, that symbol is stands for NOT. So before drawing the circuit, what we need to do is to first break the logical expression into smaller parts. So we can break the expression here. So we can see we can break expression starting from after the bracket P and R, and also for in bracket P on not R. So next we need to identify which operators are AND and which are OR. And next we have to decide whether the components should be in series or parallel. So after that we can draw the circuit from left to right following the structure of the expression. So now I will explain the circuit step by step from left to right. Starting from point A, we look at the first part of the expression, which is in bracket P and Q or in bracket P and R. So here P and Q is drawn as P connected in series with Q, and P and R is drawn as P connected in series with R. So you can see because these two are connected by OR, so both series paths are placed in parallel. So this forms the first circuit block. Next we move to the second part of the expression, which is P or not R. So this part use the OR operator. So P and negative R are connected in parallel. So in this diagram, R represent the not R condition. So this form the second circuit block. And finally, we combine both blocks. So the first block and the second block are connected in series. So this represent the end between the two main expression. So that's all from me.
Okay, thank you, Azrif. So for question 1, number Roman 2. The question is, use the laws of logic to simplify the expression. So, the first thing that I do is I use distributive law. Why? So, as you can see, this picture below this is I paste it as a distributive law formula. So, as we can see, the original form of this question is P intercept Q union P intercept R intercept P union not R. So, we can see already in this formula, which is the same, which is P intercept Q union P intercept R. So we take this left side as answer. So from this we change it to P intercept Q union R, and the rest of it we copy back. So after that I will pass it to Akmal Hakim to continue it.
Thank you, Irfan Hakimi, for the presentation. Next, I will present the next law of logic. So the next law is associative law. So why I use associative law? Because as you can see here, P intercept Q union R intercept with P union negate R. As you can see here, this symbol and this symbol is the same. As you can see here, is the same. So we can bring out the P to outside and connect with this, and Q union R will be separated with the P and become on its own. So the next law we are using is absorption law, because P intercept P union negate R. You can see here the symbol is opposite. This is intercept, this is union. And absorption law, like that, we have the same symbol, P and P, union and intercept. For this opposite, intercept and union. So with this we can combine it. Into one. So Q union R intercept P. This is the last answer for this question. Okay, I will pass it to the next presenter, Ifan Haziq.
Okay, thank you Akmal for explaining question 1. I will continue with question 2. First, I will declare all 5 primitive propositions. The first one is there is a test today as P. Next is I will go on an outing as Q. Next one is I will play sports as R. And I will go to a fun fair as S. And my last but not least, my friend will follow along as T. And next, I will state all the premises and the conclusions in words. So premise 1 is if there is a test today, then I will not go on an outing. Premise 2 is I will go on an outing, or I will play sports. Premise 3 is if I go on an outing, then I will go to a fun fair. Premise 4 is if I don't go on an outing, then my friends will not follow along. Premise 5 is I will not play sports. Premise 6 is my friends follow along. So the conclusion will be there is no test today and I will go to a fun fair.
Alright, thank you Ipan for presenting your part of the questions. Now, for question 2 part 3, we are going to translate the argument that was from the previous part of the question into symbolic logics. We have 6 of them based on the 6 premises that was from the previous question. So first, if P if and only if not Q. The second premise is Q or R. The third premise is Q if and only if S. And the fourth premise is not Q, if and only if not T. The fifth premise is not R. The sixth premise is T. Now the conclusion for all the argument would be not P and S. Now for question 2 part 4, the last part of the question, we are going to be using rules of inference to prove that the argument is valid. Now, from the list of the arguments that we have transformed into symbolic logics, we will be using the rules of inference to find the conclusion. Okay, so now, by combining number 1, which is P if and only if not Q, and 4, which is not Q if and only if not T, by using the law of the syllogism, we can get P if and only if not T. For next, we are going to combine 7, which is what we got earlier, P if and only if not T, and 6, which is T. By using modus tollens, we can get not P. Now next, combining 2 and 5, 2 which is Q or R, and 5 which is and 5 which is not R, we can get Q using disjunctive syllogism. Now next, by combining 9, which is Q earlier, and 3, which is Q if and only if S, By using modus ponens, we can get S. Now, from what's left, we still have 8 and 10. And by combining these using conjunction, we can get not P and S, which if we transform into words, the conclusion will be, there is no test today and I will go to the fun fair. And that's it. Thank you.